Distinguished guests and fellow data enthusiasts, a very warm welcome to our highly anticipated webinar on how to structure and organize production-grade data engineering projects. And we are truly delighted to have each and every one of you with us today. In the world of data engineering, where complexity meets innovation, the ability to structure and organize projects effectively is crucial for success. Now, today we have gathered here with a shared passion for data and a common goal to elevate our data engineering skills to new heights. I am thrilled to announce that our exceptional speaker for today's webinar, Pavan Kumar, a renowned data engineer at Microsoft, with a degree in information technology, wins across multiple hackathons, and over 7 years of work experience, particularly in the data engineering field at companies such as Infosys, ADP, Altimetric. Pavan brings a wealth of knowledge and practical insights that will undoubtedly enrich our understanding of how to tackle complex data engineering projects. So throughout this particular session, Pavan will guide us through the intricacies of structuring and organizing production-grade data engineering projects. So this webinar is not just a passive learning experience, right? It is an opportunity for active engagement and collaboration. So feel free to ask questions. You can type your questions and Pavan will address them towards the end of the webinar. So, without further ado, let us embark on this incredible journey of exploring how to structure and organize production-grade data engineering projects. I encourage you to take notes, absorb every bit of knowledge, and actively engage in this enriching experience. Over to you, Pavan.
Thanks for the great start, Shraddha. So excited tonight to deliver this topic, which is an important thing, and saves developers a lot of energy going through. If we have a structured project, then it that makes the data engineer's life easier than some chaotic project structure, maybe the data level or the code level. So before I present one of my favorite uh, code and data lake structure, I want us through walk through one of the architecture before we dive into the code structure and the data lake structure. Let's understand the data flow first. So then uh, I'll walk you through the uh, different stages in that particular pipeline, and how many different tools and programming languages we use in that particular project, so that we understand the complexity involved in that project, and then we understand the necessity to structure the code and also the data, so that we all have some good experience and some interest to work in this particular project. And then we'll also explore the platform to there is a great stuff in the Project Pro platform. I would encourage everyone to explore this and get most knowledge out of it. And then finally we'll go through the questions we have in the from the forum, and that is a quick agenda. Yeah, coming to the project architecture, you see, when it at first glance you see so many different tools, and I know this is a little chaotic, but when we are dealing with such big data systems, heterogeneous data systems, then this is how we do some data processing, right? So let's come one by one. So this is our data source. So this is kind of a data migration project in the first place, and then we also uh, have some day-to-day scheduled tasks and stuff. So in this project, we receive data from SAP system and also SQL Server system. We first ingest the data, historical data, to the modern architecture, like the data lake architecture. So to this is a big organization, has so many multiple um, data sets actually, and different business use cases we have. So this organization built a uniform platform, like umbrella, or they have uh, created some rules, for suppose we want to process big data, then what should be the processing engine. So they defined the hard and fast rule, like this is, if we are going to handle some Parquet file, or some complex data, that should be processed by Databricks, so that it will be uniform throughout the different business use cases. So that's how they have created these rules. So for data lake, they are going with AWS S3 as their data lake, and Databricks for the data processing. And if they want to do any AML, they want to go with the SageMaker, and using some R code. And for presentation, they are using Power BI, and Sonar for the security checks, and sorry, code checks, and check marks for the security checks. GitLab for their version control, and Airflow for the orchestration service, and JFrog for the Artifactory. So these are all the different tech stack, the tools used to manage this project. So data first comes to a sense layer, where we also call that as raw layer in Medallion architecture terms. First we get the raw data into pre-landing zone, and we do some checks whether the data sent by the upstream teams is matching with whatever we have received. So we have some checks involved in that. So maybe the count of the data and schema of the data and stuff. So then this particular delta data will be merged with the existing table in the landing merge zone. And then using Databricks, we are also changing the business rules, applying some business rules, or doing some transformations. And then we are sending the data, or putting the data into the aggregation layer, where we also call the unification. And further refinement is required, then we also put the data into refinement zone. So we, based on this different data zones, we understand which quality of data we need, because as different teams, we might need data at different level. So we might not need the completely curated data, which is specific to one use case, but we want to get, we also don't want to start data receiving as a raw data, because some sanity checks, are some basic validation is already done, and we are ready to use. For suppose I am a team A has already done some validations, and the data is ready to use by any other team which is interesting in that particular piece of information. So in that case, that particular team B needs not to take from the original data source, rather than it can the team can leverage the data which is already processed to some extent, and further they can take and apply their business rules on the top of that data. So that is how this whole architecture is designed. So it goes to sense layer first, then comes to aggregation layer, and finally that comes to the access layer or the publish layer, where that finally all curated, cleansed, and the business rules applied data will be present in the publish layer. So in here, in the publish layer, we are using Snowflake as a data warehouse or virtual data warehouse, and from that the data will be visualized using Power BI. So this is a a high level data flow. So this is the project architecture. So if we go to the stages involved here, so we have a lot of code, right? So for that, in fail safe environment, if we want to, we want to deliver some, we want to release some version, but maybe because of some other factors, that version is not stable, then we want to go back to the previous version. So for that, we need to have a versioning, maybe using some tags for that particular build, or for that particular code and stuff. So for that, we need to do the versioning of the code. And then every time we build a new code, we need to do the unit testing. And then we also need to do a security and vulnerability checks using check marks, and code quality using sonar analysis. These are all required. So most of the well mannered, well organized projects will have all these things. But sometimes, based on the complexity of, and based on the requirement, we might not use all these extensive list of tools. But these are all recommended to have, for to have, or be ready for the future. So the code quality will be done by, code quality analysis done by the sonar. And then we do the build and packaging the code whatever we already have. And then we archive the artifacts, maybe the wheel files or the jar files or whatever, packaged code will be in the archived in the artifactory, like jfrag I mentioned. And then we also have, then promote the artifact based on, maybe we do this build for dev, then we build the code using the Jenkins, and we promote it to dev, or QA or UAT environment, and then further to production environment. So that we need to do the promotion of this artifact, or the deployment of the artifact. We call also the release, based on different terminologies. And then so the code here we are using um, Airflow for the orchestration of the code. So when I say orchestration, the scheduling of the jobs and stuff, right? So that orchestration we are using Airflow here. And then Databricks, as I mentioned, we are using this for the data transformation, and applying some complex business rules on top of the data we have. So that is a deployment step. And then ETL onboarding. So ETL onboarding is nothing but, for every organization, uh, these days we are creating some reusable components to easily onboard some new data sets. For suppose I have 100 objects, I need to migrate from my legacy system to the modern data lake kind of architecture and stuff, right? So in that case, I don't want to repeat the same code. Like, for suppose if I want to read some data from SQL, if you know about the Spark thing, so I at least need to write some code to read the data from SQL using some JDBC connection. But that is a repetitive task, or the same. This can be automated, or this can be a configurable thing, rather than writing a code every time, right? So for that, most of the organizations are going with some configurable components. So that is nothing but the ETL onboarding process here. So when I want to get some new input data source, like I want to read table A. So in this ETL onboarding, what I'll do is, I'll have a JSON file, and I'll just mention what is my input source and what is my output target path. So these details will be there in the JSON file, and this JSON file will be hosted in any a basic or minimal RDBMS system, and from that system, the uh, uh, ETL framework will read the information, what is the source and what is the target, and then this will be parameterized and sent to the Databricks job. And that Databricks job accordingly read the data from source, and does the transformation, and then uh, push it to the target data lake path, or Snowflake in this matter when it is published layer. So this is what happened using the ETL onboarding. So in this case, we are using some configurable JSON files. And then sanity testing and stuff we need to do, because the check sanity check, if we want to check for any functionality if we add some new releases and stuff. So we need to make sure that existing business functionality is working as expected. So we need to do all these things in this particular pipeline. And in this pipeline, we see many different tools and programming languages. So we have Airflow. We in this case, in the Airflow, we are using some Python scripts, and the pipeline will be built using Groovy script. And the data processing, as mentioned, we have Databricks, and in the Databricks we might handle some Python notebooks. Scalar notebooks are for reusability, and for that matter we can create some packages, maybe wheel files or the jar files. These kind of things we generally use to reuse the code. So when we build this jar file, it is easier to import and do some custom code. Custom code will be built as a jar file or wheel file, and then it can be leveraged in another Python file. So this is the code structure. And we when we are reading data from SQL, data warehouse, or or we are writing the data to Snowflake. In this case, we are using SQL as our programming language, and then we also have some config files, like some static text files, and we also might have some CSV files, or for as I mentioned, for onboarding, ETL onboarding, we are using JSON files, and for PyTest we are using Python, and Sonar we put some property files. So this project involves these many different programming languages and different kind of data. So in this case, it is very much important to organize our code base and the data lake in such a way, whenever there is some troubleshooting needed, we need not to search or scan through the complete code base or data lake, but based on the naming conventions and based on the structure, we can easily navigate through the code base and understand where this is happening, and easily we can fix those issues. So in the very case, we need to organize the data and code. When it comes to uh, data, uh, we generally see this medallion architecture. So where we have a bronze or raw stage, where we just receive the data from our upstream, and we just do some a validation, maybe at row level counts, or some all the packets which sent by our upstreams is matching with the downstream and stuff. So those kind of basic validations we do on bronze layer, and then we do some schema, we apply some schema on top of the raw data we have, and then do some transformations we need to do. And finally this transform data will be put into the gold layer. So the gold layer is nothing but the data is ready to uh, be visualized for the usage. The end users can leverage this gold level data. So that is maybe some aggregated levels, or all the business rules are applied on top of that raw data. So this is how the data goes. So in this case, when we segregated this data into these three different layers, we might go with for suppose if we are using Azure blob storage or Azure data lake as our data lake, then we might create different containers, storage containers for these three different levels of data, like bronze, silver, and gold. In case of AWS, we might create some three different S3 buckets, and that is how we manage our data. So we know what where to go when there is some issue we face during any data transformation, or any for any debugging, we can easily go to that particular stage, and we can debug easily when we have this kind of structure. So otherwise it will be so much chaotic, and we don't know where to go for which kind of data. When come to the code organization, uh, Okay. This is how the the tree structure looks. So Shraddha, can you confirm that you see my full screen?
Uh,
Uh,
y- yes, Pavan. Can you maybe zoom out little? I'm not sure what. Zoom out, zoom out.
okay,
No, no,
fine.
no. Yeah, yeah, I think the entire screen was visible. Yeah, unified is the, yeah, correct. Yeah,
Okay, fine. Thanks for the
correct,
confirmation.
correct.
Yeah.
No
So
problem.
yeah. Yeah. So here we have the tree structure for the code we are going to organize into. So I can better show you my Git repository for better understanding. So let's go by the folders based on different tools we are interacting with. So we have Airflow for the orchestration of our jobs. So everything related to Airflow will go into this particular folder, and you can see multiple scripts are there which are responsible for for suppose taking uh, one script where we are creating the DDLs. So in this particular project, we are creating DDLs also using Databricks, because by the time when we are working on this project, there was no schema change Python library for Snowflake. So for versioning and stuff, we choose this path to better version our code and stuff. So we have all the DDLs in this script. So this is a Python class. Sorry, this is okay. So this is a DAG where how we want to uh, start the creation of our DDLs and monitor that and notify if there is any failures, or if it is successful, then these will be shown to the responsible point of contacts, and then do any dependency check whether it is completed or it is waiting on something else and stuff. So these kind of DAGs we create in Airflow. This is responsible for creating the DDLs, and we also have some incremental kind of DDLs. So we going to put those DDLs in this particular script. In the same way, we have historical scripts. So that means when we want to do a full load from the upstream, right? So as mentioned in the previous slide, so here, for the first time, when we are migrating data from the upstream, we want to get all the data. So this is a full load that we are calling the historical load. So historical load will have the sequence to truncate the table or create the new table and put it the complete data. And in the incremental, we might based on append or merge, or based on that, we'll have a different code. So for those what do you call this kind of operations, we have different DAGs for that. So that DAG, this particular incremental DAG, will call the incremental data push scripts written in Python, and that runs in the runs again is the Databricks processing engine. So that is how we have multiple different Python scripts which will have Airflow DAGs. So whenever we want to do any changes to particular DAG, we come here and find out which DAG I need to change. Because the names itself making some sense. So if I want to change some code in the pre-landing related processing, then I come to Airflow and change the scheduling time maybe. In the beginning, we want to run this job at 1 a.m. in the morning, but later we thought we need to push it a little, so we want to schedule it by 12:30 a.m. in the morning. So we just come here and change the scheduling. So in the same way, we have some configurations, right? So as I mentioned, whenever we are getting the data from our upstream, we want to do some schema checks, whether based on the prior agreements, we want to get some 6 or 7 fields from this particular feed, and that all should be having some strings. First three fields are strings, or maybe second two fields are integers, and the other one is a boolean value. So in that case, we need to see whether the particular schema is coming, and also the count is matching. For doing those kind of validations, we need to have this schema. So this is a static schema file. So we can define this once and leverage it based on the necessity. So for that, we'll have this config file. So when there is some a schema change happens, we just go to the schema JSONs folder in the configuration folder and change this and push it to the remote branch. In the same way, we might have some other static files where maybe a text files or CSV files, to pass some parameters and stuff. And then the ETL onboarding. So these I mentioned, right? Like a framework metadata will manage through the JSON files for different target layers. We have different transformation logic, and our source and target uh, paths are the places changes in the architecture we just went through. So based on that, we'll have different uh, input and output. Uh, uh, Input, what is my source of the data, and what is my destination of the data path, and everything we define it in the JSON files. And then we onboard this using the pipeline in the Jenkins, right? So I'll come that in a later point of time. And in the test, we need to do uh, unit test. So whenever we are adding some new code to the existing transformation logic, we need to do the unit testing. So that can be automated using some PyTest or Scala test, or based on the language we are using to do the transformation, we can use different libraries and do the unit testing. So in the same way, we also do the sanity test to check whether the business requirements are meeting, after we modify this particular code in the current release and stuff. So for that, we need to have all the unit tests. So these are all actually run in one container using the Jenkins, right? So we use the Jenkins in some projects to do this build and deployment, right? So in that case, these sanity checks and unit test cases will run against one of the containers, and in that stage itself, we are going to do the ETL onboarding, the uh, JSON files we prepared to mention what is the source and what is the target to a particular Databricks notebook, or the uh, uh, jar file or the wheel file, based on the requirement. So here in this case, we actually mostly use the notebook approach, because that is easier to interact with. And there is another argument also, to have the reusability and stuff, we need to go for any wheels and jars. But I never faced any issues in these both approaches. But based on the knowledge and the resources we have, I think we can go with either of these approaches. So yeah, coming back to this point. So in this retail onboarding, we do a REST API call to onboard this particular JSON, what is a parameters to particular Databricks, so that we put into the database. So whenever there is a need to change something in the ETL onboarding code, we just come to this test folder and do the ETL onboarding, right? Then we have the code base. So this is our workspace. Whenever we are modifying any notebook, we we come to the workspace and go to the notebooks and do changes in the respective folders. For suppose I want to modify code of the incremental load when my target is the published layer. So in that case, I come to here and work on what is the existing logic and how I need to modify this particular code base. So this I can do easily when I have the folder structure in this way. So if I want to update something in the application version of a particular thing, I can come here and see what is my target uh, target data zone, and I can easily modify the code in that particular code base. And then we have different files in here. So these are all actually not having multiple versions or multiple classifiable code base. So we'll have a single file. So this is actually responsible for building and deploying, and this contains all the pipeline. So this is a groovy script. So this groovy script will have all the stages to do this versioning or unit test, build and deploy, and do the check marks thing, sonar analysis and stuff. So this is a single category here. So we can have it in the root of this particular code base or the repository. And then generally people will also put some exe files and stuff, but generally this is not advisable. Generally we'll have the source file and then do the deployment. But sometimes these kind of executable files are very minimal, so it's okay, but it's not advisable. So, and in the other files we might have some requirements to uh, install some libraries for the Python scripts and stuff. For that, we use this requirements .text, and we mention all the required libraries. And then we also mention the rules or the properties in Sonar, so that for suppose Sonar, a high level thing. So sometimes we end up writing multiple regular expressions, right, in the code. So it's not quite recommendable to have uh, regular expressions, because it might breach some code like it can create some code vulnerabilities. In that case, this Sonar will go through scan through all the code base and find out the any code breaches, or whether that is whether the repo is following all the best practices with respect to the coding or programming stuff. So in the same way, we can also have check marks where we'll see, some SQL injection kind of thing and stuff, right? So those kind of security related, vulnerabilities can be find using the check marks. So we can have that particular file for the check marks properties in the same way in the repository. So this is the one of the ways we organized our repository to make ourselves easier. So there may be some different organization of code. It basically depends on the use case and the scenarios, but whatever experience I have with data engineering, I find this is so much organized, and I never felt, do I need to go through these many and stuff, right? So because end of the day, this organization may look okay. This is a simple thing. I can go to this particular place anytime. But when we are doing the same thing repeatedly, we feel this is not organized, and we end up spending so much time going here and there. So it's always recommended to have some structure of code, which can be easily accessible, and we need not to remember particular place to go through, but we should have naming for different files so that we can easily navigate through. Even some newbie comes to this report to explore, he or she should be able to navigate by themselves to understand, okay, what is my code to change something when my target is my publish layer or the landing zone, or landing merge zone. So that is how we need to uh, clean up and maintain the code repository. In the same way, we also need to organize the data based on the quality. Maybe it's a bronze standard, silver standard, or the gold standard. So that organization, the structure apply to the data lake, and this code structure, the folder structure will be in the respective repository. So coming back, so this is pretty much you know uh, an example of well organized code base I have gone through, and I wanted to give you a glimpse and direct you to make yourself your life easier, and take it from there. So I would like to introduce one of the projects in Project Pro, where we have a Lambda architecture, where we are getting data from log analytics data, and then we are pushing the data into different layers. So it would be a great use case for you to explore Spark structure streaming, and Spark data frames, and some visualization, and explore some features of Cassandra. So I would like to recommend you to go to this particular uh, uh, project, and design your uh, uh, code base and also the data lake in an organized manner. So you will see what is the architecture of this particular thing, and you can consider this as a an assignment for yourself, and create and structure the code which provided in the uh, code base presented here in the particular project. So you can find all the codes in this session, in this section, and you can upload it to your personal Git repo, and have a look how well you can structure based on the the glimpse I have given. So this is one part of this the recommendation, I would say. And then I would like to walk you through the Project Pro library, where you can create a path, the learning path. You can create it by yourself based on the interest you have, or you can connect with any of the experts we have, who are very friendly and can guide you through what is your current skill set, and they can guide you accordingly how you can build this learning path, and based on your interests and the targets you want to achieve. So so go through all the projects you have, and I would suggest everyone to at least go through the architecture diagrams of each and every projects, where you understand different tech stacks involved in a particular project and stuff, and based on your interest, you can take one project and continue from there. So interestingly, these days there are so much buzz around the data build tool, which is a simpler configurable tool to interact or do some transformations on your relational database and stuff. I still need to explore this interesting tool, but we already have delivered some very interesting stuff about the DBT. You have these two projects, and I am also planning to go through these projects sometime when I get some free time. And I would highly recommend you to use this, because as a data engineer, you might encounter this tool in your day-to-day life, and this will be a great start. So we have two projects already in the platform. So I hope you get some insights with respect to the DB tool. And I think with this, I pretty much covered the project structure and the benefits of Project Pro. And by the way, I can tell you that I've been uh, a student, or a data big data enthusiast before, and I went to different platforms, but I never felt everything was kind of theoretical at that time. That time I don't think I didn't find the Project Pro that time, but I wish I could find this Project Pro when I was in looking for good resources. So everything was in theoretical format and stuff, but in Project Pro, we are giving our best for everyone to know how the real-time projects look like, and we are giving a great services to every customer we have, with all the one-on-one sessions and different mediums. So I would strongly recommend you to explore the platform and get the most benefits out of it. With this, I think I'm open to go through the question and answers.
Okay.
AR,
Uh,
namaste. Yep.
Hi, Pavan, can you see the question and answer? Uh,
Yes, yes.
yeah, so maybe you can start off by answering Prateek's question on, do we have any PySpark project on Project Pro which is organized according to production grade project structure?
Yes. So the one which I just mentioned, the log analytics project, that is a PySpark project, and that is actually we started with simple, explanation at the time, and now we are going to whatever projects we deliver, it will be in production grade going forward. But the one which I just showed, it has all the basic things, and you can take that up as a exploratory task for yourself, and structure the code base based on the insights you get from this session, hopefully. And you can architect the particular pipeline based on the best practices. um,
Prateek, do you think
yeah,
that answers your question?
I think these DBT links, I think Shraddha, can you share across the attendees, or how you plan to share the DBT links?
Sure. Yeah,
Yeah,
sure. We'll send across the presentation of the along with the webinar recording. Yes, the webinar is recorded, and we'll share the recording after the webinar
yeah.
ends.
So Shilpa, answer to your questions. I don't think we have any projects open source, but you have the recipes, which mostly cover technical aspects of each and every technology and tool. So that will surely help you to get started, and based on the quality we have given in the recipes, I think you can consider subscribe to Project Pro. So I'm not a great fan of certification, rather working on different projects and get knowledge out of it. So, but yeah, there are different certifications in Azure, like is DP 200, I guess. I'm not so sure, but I think DP 200 for the data engineering fundamentals and stuff. So you can try that, but I would strongly recommend you pick up one project and understand the flow and stuff. So I'll go to the questions in the beginning. I think there are some questions. Uh, um, I didn't quite understand this question, Vatsala. What is the Lambda picking up here? Is there an API connection with the tip? So, are you say the TIBCO? So, TIBCO is out of topic in this particular, data engineering project actually. But yes, I think there is an integration. So, in this particular project, whenever we are creating a detail out of any file, the a feed in the data lake, we mention what is the source and what is the target for this particular table. Based on that, we created the lineage and data catalog. So we use TIBCO for maintaining data catalog and the data lineage. So I hope this answers the question. I'm not expert of TIBCO, but the usage of TIBCO was to create lineage and catalog for the data. Hope that answers. What is the basics of classification? Yeah. So bronze is the raw data, whatever our upstream sensors. We can have a pull and push mechanism. Sometimes we pull the data from upstream, and we don't do any transformation on top of this data. So this is our first entry into the system, that is the landing zone, and we just do some data basic validations, and then we put the data into the next silver grade data. That's where we apply some transformations and business tools. So that is the second stage, and the gold layer is the gold zone is the final usable, or all the aggregated data and all the business tools applied on top of the data and ready to visualize. So that is high level of the medallion architecture. Uh, this is a private repository, but I can share the project architecture for you to go through and understand things. I can share, or maybe for the skeleton I can create another public repository and share it across. I think Ashreda can send this to you guys when she share the DBT links and stuff. So that is possible, right, Shweta?
Yeah, sure, sure. Yes, Pavan.
So there are so many questions about the recording. Can you take that up?
Uh, Pavan, but
Like,
before that, we have two people who've raised their hands. Let's go ahead and speak to them, and then
sure,
we get back to you.
sure.
So we have Mani Maran. Mani, you can go ahead and ask your question. I've unmuted you.
Yeah, hi, thanks. Pavan, hi, first of all, thank you for your session. It was very
My
much
pleasure.
useful. Yeah, so just some couple of questions, doubts
Mm-hmm.
I have.
Mm-hmm.
So you spoke about Airflow, right, for
Yes,
orchestration of the. So in
correct.
case if you are using Azure Data Factory,
Mm-hmm.
so can it replace Airflow, or do you still need to use Airflow?
Yeah, so these are alternatives, I would say. So in case of data factory, I think you can create ARM templates. If I'm not wrong, yeah, it's ARM template. So where you can create JSON templates out of the ADF pipelines, and you could take it from there. So yeah, ADF can be an alternative to Airflow. So when you planning to use ADF, it is
Okay.
far more better than Airflow, because it has got all the UI components, so you can drag and drop required components. So it also has some predefined copy activity and stuff. So it's easier than Airflow, I would say.
Okay, thank you. And another thing, like you said, the bronze, gold, no, the
Mm-hmm.
data
Yeah.
is saved in different containers in ADLS, right?
Yes.
So in real time, is it done like that? Because I heard that when the data is refined, the prepped data is sent to the SQL warehouse for downstream like that. So like, I don't know, so both are possible, or in real time, how is it done? Any idea?
I didn't quite get the params thing. Can you repeat that?
The when you get the raw data,
Mm-hmm.
you prep the data, right? And then the refined, the gold standard data, which is used by the downstream, is it sent to SQL warehouse or any data warehouse, or like you said, it can be saved in different containers in ADLS?
Oh, okay. I think I understand. Like, so this is a logical classification. So there is no hard and fast rule. So if you want to include any RDBMS kind of thing like Snowflake or something, you can very well have the RDBMS system in your final gold layer. And when it comes to the data itself, you can create external tables on top of the data, right? So you can define the DDLs on top of this, maybe a different parquet. Like, so yeah, best thing I wanted to suggest, like whenever you are doing all the transformation, so from raw layer, you get the data as is from your upstream, and it's highly recommended to use parquet across all the other layers. So, and in the final your published layer, you can create external tables on top of this data which is there in the published or the gold container. And you can, yeah, to your question, you can have RDBMS in the gold layer. So it's quite possible. So it's just a logical classification, so no hard and fast rules.
Okay, so the last question, like for code migration, the which environment you suggested? Code migration.
Oh, code migration, like so you mean the version control like Git and GitLab and some other things, like you mean to say that?
GitHub, I think you are using it for as a repository, right? For a
Yes,
code
yes,
repository.
yes, yes.
For code migration to different teams, like what environment are you using?
So code migration, you mean for suppose you have SQL in your legacy system and you want to do a betterment on top of that, and you want to create some modern architecture, is it? Like, I didn't understand your perspective when you asked the question. So code migration,
So,
yes, it
yeah,
based on the processing engine we use, right?
okay, fine.
Like for suppose I have SQLs in my legacy system and I want to my data is increasing exponentially and I want to go up some big data solution like Databricks or Azure Synapse and stuff. So in that case, I either go by Python, which is the easiest language out there in the market. So I would prefer Python, but there are developers still prefer scale over Python for Spark to get the Spark performance. So I think I answered the question.
Okay, thanks, Pavan. Thank you so much. Yeah, thank you.
Thank you. And this is an interesting question. Yes. Uh, so the MS Fabric is kind of it's based on the Delta Lake architecture, where you will get the benefits of Data Lake, as well as you can enforce the ACID rule, or all the benefits of you having some RDBMS data warehouse. So it's similar to what Databricks offering right now, but because the MS Fabrics uses all the Azure, you will have multiple other benefits also. You can easily migrate from whatever data lake you already have. So yeah, this is the high level things, and there are some, and it's easier for you to interact with your data. So yeah, so there are some interesting work is happening, and you will see that in public forum very soon. Yeah.
Okay, Pavan, we have Ademola. Ademola, can you please unmute yourself?
Okay, thank you for this session. Can you hear me? Do we get help to walk around those things and then continue learning on the project?
Yes, yes. So this DBT is some, the new topic in our platform. But yes, the such issues and such upgrades we are already working on. For suppose you take the
Sorry,
scenario.
Pavan, but your voice is not very clear.
How about now? Is it any better?
Yeah, better now.
Yeah, sorry for that. Yeah. So we are actually working on the similar projects to upgrade with respect to the latest interface. So if you have such issues with the DBT, I think you can have a session with an expert who can correlate what is existing UI and how can you navigate through the new UI. So that is the quick and easiest way. But we are working
That's
and upgrading our projects already.
excellent. That's good. That's good. Thank you.
Yeah. Yes, and Tapelo, this question, yes, it has a real-time analysis of the log. So you go through the structured streaming way to read from logs being ingested to the Kafka topic through an iFi, and so that whole process is in real-time analysis with some open source log analytics data. So, is there anyone?
Yes,
That,
yes, yes, Pavan. So we have
Mhm.
Bhanu Prasad. Bhanu Prasad, you can unmute yourself and then.
Yeah. Yeah, hi Pavan. My question is, I think I just want to see any project, right, using Azure Cloud or any Azure Cloud, okay, using Snowflake, and the source might be the SQL Server, like migration from SQL Server to Oracle, uh, or generally like we currently we will no, we are using SQL Server, and we are when we are doing no POC and Snowflake. So we have the, I mean, our source will be the guideware, and we'll from that, data will load into the SQL Server, target, that is a source kind of thing. Using stored process, we load the data. So my question is that how much data? I mean, Snowflake is providing Snowpipe, right? So I mean,
Mhm.
when we have the files in the blob storage or AWS S3, so we can use Snowpipe, and then we can transform using dbt or SQLs. So it provides streams and all that. So if based on, if the data is less data, or like we when we run like daily or monthly jobs, in that case we can use Snowpipe. Like some projects like which are less data, right? Or if you have like data like consumer data, or daily data like healthcare domains, social media, these data will generate daily. So for that data we need to use Spark ETL instead of using Snowpipe. Or for that also we can use, because Snowpipe is, it's not a complete ETL functionality, right? Just loading the data, transformation, I think the copy commands will be there. So in which case we need to use like I mean uh, like for the law, I mean daily lot of data is there, lot of streams is there, then we need to use Spark. Or in that case also we can use Snowpipe, and we can use dbt for transformation. Or like suppose we have because suppose we have any ETL jobs are there. It's like for automation we have some
Mhm.
SSA jobs are there. So that automation jobs, I think we cannot, I mean, Snowpipe, we cannot use, right? Because it is just for loading the data. For that automation kind of things, right? Like through using the stored procs or SQLs, generating the files, and from there we can load into SharePoint sites. So those some automation kind of, suppose any ETL jobs are there. So that, suppose we are using SSIS, and we are, I mean, we suppose we are going to use migrating to the cloud using AWS Azure, because Azure means. So can we use Azure Data Factory, because Azure Data Factory, I mean, there is option is there, right? We can
Yeah, yeah,
migrate or something using SSIS. So that part we can use ADF, and other just daily data feeds. For that we can use Snowpipe, or for that also we can use Spark, or I mean, there is some scenarios where we need to use Spark, and where the scenarios where we need to go for Snowpipe. And generally, we are using for on-premise, we are using ETL, right? So for this also, any purpose, any kind of no
yeah, yeah.
thing, like we
I
need to
get your
use
question.
ETL only, avoiding the this thing Snowpipe and Spark ETL, which is the
Yeah,
best
yeah,
option.
yeah, yeah. I understand, Banu. So, see, Snowflake itself has everything. Like it basically suggests the output. After that, you do the transformation. So this process, I think I still need to explore the DBT, but here comes the DBT solution, where you can completely manage your code and data modeling stuff, everything using the DBT. Okay, so this is for the the code architecture and stuff, but you are going to leverage Snowflake virtual warehouse. The basically the Snowflake's compute Snowflake's compute. You are going to use Snowflake compute when you are trying to use this Snowpipe, or or want to schedule using tasks and stuff. So everything in the inside the Snowflake, and everything in the uh, Snowflake cloud itself. And it may be different, like whether Snowflake is using Azure as its data lake, or AWS or GCP, because Snowflake offers everything.
Yeah.
Yes, so these three cloud at least. Okay, so that is one thing. So you are going to use computation service of Snowflake, and monitoring the organizing the code using DBT. That is one way. But you feel that you have loads of data, and it is increasing exponentially, and you want to migrate to the Databricks. Then you can use Snowflake storage, and use your Databricks, or Azure Synapse for your processing. Okay, then store the data in Snowflake just like any RDBMS system. So that you can do. So based on the data you have, and based on the skill sets you have, and based on the requirement, so it depends on many other things, right? The project perspective has so many other factors, but you can use everything, and you can actually have a mix and matching of these tools. But when there is a big data involved, I would recommend you to go for Azure Synapse, or the Databricks, or at least some Spark based processing engine.
Azure
Otherwise,
Synapse is also
Snowflake
similar
itself is there.
to Snowflake, right? So it is also
Mhm.
kind of database only, right?
Yeah, database with all the excuse me. Yeah, so database, and also it also offers the compute, right? So you can
Yeah.
leverage the compute to do your ETLs, sorry, ELTs.
Okay.
It depends on the data you have, the growth in your data.
Okay.
Hope that answers your question.
Mm, yeah, okay. So can we have a kind of a product like which no which I asked a question like, so
Yeah, base. Yeah. Okay. Yeah.
when we need to go for database,
Yeah, yeah. Let me ask. I remember that one, the question. So Banu, you might find all these combinations are, we are trying our best to have different combinations of these tech stacks, but we have some, you know 20 plus, at least 20 plus technologies. So we cannot have every combination possible, but I'm sure you find SQL Server as your source in some project, and Snowflake as your target, and Databricks as your processing. But I'm not sure at this point we have the combination of these three, but you will get projects where you have all these things involved in any of the stages. So just explore the project, pro. if you just go through the architecture design for each and every project, then you will find the the required things, and you can take it from there. But we can take that as a feedback, and based on the demand we have, we might create one project based on this tech stack. Shraddha, can you note down if it's okay?
Yes, yes, certainly.
Yeah, thanks, Manu. So, do we have any other questions? I mean, hands up,
Yes,
Shraddha. I don't
yes.
see.
Yeah,
Uh-huh.
thanks, Panu. All right, so we have Venkatesh. Venkatesh, you can.
Yeah, hi Pavan.
Hi.
Yeah, thanks for the informative session. So I'm having a question regarding a POC. I'm doing a POC on I have uh, 5 different data sources over here, and I want to use like Azure Synapse. I want to leverage Azure Synapse
Mm-hmm.
as a data integration tool actually. So I want to migrate to the Azure SQL dedicated pool all the data.
Mm-hmm.
So I'm having around 600 plus objects across the data source, across these 5 data sources.
Mm-hmm.
It might be like tables or files, whatever it is. Basically,
Yeah.
if you choose, all are in CSV files. So I'm landing all these files in my ADLS Gen 2.
Mm-hmm.
And from there, I want to, as a Parquet, I want to land in ADL Gen 2. From there, I'll move to the SQL dedicated pool. So my question over here is like I want to configure. I want to create a configuration table where I will mention all my like object names and everything.
Yes.
It means like source name and target structure name, everything. And I
Yes.
want to leverage that configurable table so that each and tomorrow, if I get another data source, other objects, I will add those into that configuration table, and my ETL or ELT pipeline will pick up those things. So according to the Synapse architecture, is this is the best process, or else I need to build individually all the individual 680 objects to migrate to the Azure Synapse, Azure dedicated pool, and run them as parallel. So which option is the best one? Like what will be the best according to your?
Yeah. So to have some configurable thing actually helps. So that's what I even mentioned in the this ideal
Right.
onboarding session.
Yeah.
So you can build the similar way where you
Mhm.
can mention the source and target. For suppose if you're using Synapse Spark pools, so you can send these individual job parameters where you will have the source and destination tables, like
Right.
source table or
Right.
destination, and you can even pass whether that is a SQL CSV file or different file like
Mhm.
Parquet file, or it's a table, whatever
Yeah.
parameters you want to pass, you can
Okay.
pass. So for the simplicity, to start with, you can have JSON file itself, and then parse it to the your processing engine like Databricks, and
Mhm.
then read this one for simplicity. And
Right.
then the next iteration, you can create some metadata database where you will uh, 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 convert this JSON structure into a columnar structure, or the table structure using
Okay.
some API calls and stuff. And after you create the table, you will read the table data as a parameters to your Databricks Java Synapse job.
Okay. So actually, what my small confusion over here is,
Mm-hmm.
if I build a configurable table and I run the process, so it will be looping through each and every object and reading it, and then it will go to the next object, right? Is it limiting any parallelism, like the
Yeah, yeah.
parallelism concept which is provided by Azure Synapse? Are
Yes,
we limiting that parallelism which is over there?
correct. So we can have the parallelism also. Databricks gives you the parallelism thing, so you can limit up to the as many jobs as you want.
Oh,
I can show you the parameter itself here. So where you can mention how many parallel jobs you want to run. so that you very well do that. That is possible.
That is possible, right? So even if I configure a metadata table, I can do the parallelism. I can implement parallelism in that, so I can run the individual job parallelly.
Yes. So here, if you see where I mentioned the priority, right? So
Okay.
this priority of similar priority will run at the same time for some,
Okay.
and you can mention how many parallel runs can happen in a given time.
Okay.
Because why I'm having this priority, because I might have dependency on some particular object, so I should process object B only
Okay.
after object A, right? So
Right,
that's why
right.
I am prioritizing the order of or the sequence of the runs,
Okay.
and I can give in that particular batch how many jobs can be run. So you can very well do that. At least Databricks and Synapse will give you that feature. You can
Okay.
explore the REST API call to these things. So yeah, it's
Yeah.
there.
So configuring a metadata table is the best is the correct approach, right?
Yes,
Don't,
that's
yeah.
right.
Okay, fine. Yeah.
That's
Thanks,
easy,
Pavan.
and you
Yeah.
can easily onboard new datas. Yeah.
Right,
My
right. Yeah. Yeah. Thanks so much, Pavan. Thank you.
yeah. Shraddha, I think we're 20,
Correct.
20
Correct.
minutes expected.
Correct.
Yeah.
Do you want to take just one last question before we wrap up?
Sure. Yeah.
Great. Great. Harish, yes, go for it. You can speak.
So, hi, Pawan. There's one question here. As you rightly mentioned, we can use a Snowflake as a storage, and for compute or the legacy processing, we can use two options. One is Snowpark, which is coming from the Snowflake, or the Databricks, right?
Yeah.
Do you have any comparison, like which one is better? The Databricks is better, the Snowpark is better?
So I'm Databricks is my favorite because I can do anything possible. The customizations it will give me. So when it comes to, I'm telling you, as in a programmer's or the developer's perspective, okay, the cost and something maybe vary based on the the data we have, the amount of data we process and stuff.
Able to hear you.
I'm sorry.
I'm not able to hear you. It is breaking.
Oh, is it better now? I'm not sure
It's
why.
much better.
Can you hear me now?
Yeah, this is fine now.
Okay, fine. So I was telling, in a developer's or programmer's perspective, I myself like to code in terms of Scalar, Python, because of the reusability and customization I get. Whereas in Snowflake, it is still limited, right? So it started with JavaScript, the UDFs are the procedures you want to write. It will give you as a SQL or the JavaScript. And now I think slowly it is giving more support to write these customizations using Python. But still, I feel a pure Python programming gives me more flexibility to write some custom code and reusable components and stuff. So with respect to that, I choose Databricks if I have, I can choose between Databricks and Snowflake. And also, it's powerful. So Databricks are the Synapse, Azure Synapse are, powerful data processing engines when compared to Snowflake also. And I feel I'm not quite sure, but even with respect to the cost, Databricks is, I think, better when it comes to the casting things and the support you get. I worked on Snowflake. There is no doubt it has everything, like within other database or warehouses. I like Snowflake much because of its micro partitions and the clone stuff. So everything, like you can do the time travel and stuff. Those kind of features as a data warehouse solution, I liked it. But the processing engine, I would choose Databricks. Yeah, it's just my opinion, but based on the volume of data you are going to process and the cost and other factors. Based on that, I think you can take a better decision. The feasibility study is must when you want to choose between these two for your projects.
Great, Pavan. That is helpful. Thank you.
Thank you.
Okay, thanks a lot, Pavan, for answering everybody's questions. Folks, so I will be sending a link. We would love to hear what you thought of the webinar. So please, I request all of you to please.
I guess if we want to pursue some of the projects available in the Project Pro, whom should we reach out to?
Harish, you may reach out to me. I'll just ping you my email ID. I'll ping it on chat. Yeah, please go ahead and send in any queries that you have regarding the webinar or what you'd like to see. Just any query request, and we will look into it.
Project Pro, the only solution for solved industrial grade projects.